Hello, everyone. Hi, everyone. Thank you for coming to our SNOMED AI Symposium. I know this is the session right after lunch, so we will try to keep this on time and also fun and invigorating for everyone. Hi, everyone. I'm Susie Roy, Customer Relations Manager for the Americas, Collaboration Specialist and Research Engagement Lead at SNOMED International. We're really excited to have our first SNOMED CT AI Symposium, and today we're theming this around building foundations. A lot of organizations are really excited about AI, but what does this actually mean for us here at SNOMED? And so we're hoping that today we'll be able to start to dive into some of that. I'd like to call up our CEO, Don Swede, to the stage to give a couple of words of welcome.
Thank you. Good afternoon. Is everyone still awake? Good. I just want to let you know that I am an AI-generated hologram, very realistic. Sometimes I'm correct and sometimes I'm not. No, in all seriousness, welcome to this event. We hope to learn lots of good things, and we'd like to learn also how we can leverage AI for the good, and also for the good of humankind, especially as it relates to patient care. I'm not going to say any more, but if you have questions at the break and you want to have a talk, I'm around. Otherwise, just enjoy the event. Thank you.
Thank you, Don. Okay, so as many of you know, as part of my work with the research engagement, every single SNOMED Expo, we have a little bit of an event. The very first one, it was a small discussion forum where a couple of us sat in a room and we said, research is cool. What do we do? The next one, we actually started to workshop it, and you guys all helped me develop the roadmap and the strategy around research engagement. Well, it has grown and grown and grown, and here we are today with an AI-focused symposium where we've been able to bring in some vendors, we've been able to bring in the research community as well as the clinical community. So we're hoping that today will be really exciting. So just to give you a little bit of an idea of what today's event's going to be, we're going to start off today with Ms. Paula Braun from the CDC ONC. She's going to give our keynote presentation. And then for those of you who know me, you know how much I love K-pop. And so I wanted to bring a little bit of that into here. So we're going to have a couple of video recordings, VCRs thrown out. We're going to have Dr. Halamka providing us with some words about what AI versus generative AI means. And then we're going to switch over to our panel discussion. And this panel discussion is going to discuss the role that SNOMED CT has and terminologies have in AI. Next, we're going to go into a break. And then when we come back, we're going to have another one of those VCRs. And you're going to see those VCRs are kind of thrown in to kind of help when we have like in the K-pop world, costume changes. We're going to have shuffling of our new panel coming up and panel leaving. So we're going to try to spice this up a little bit for you guys. We're then going to have an inspiring presentation from Mr. Charlie Harp from Clinical Architecture. And then last but not least, we're going to end today with some words from our Chief Information Officer, Rory Davidson, who's going to also make an exciting announcement about an entity linking challenge. And as excited as I am about that one, I don't want to steal his thunder, so I'll wait for that one. So we have a jam-packed day, and we hope that you guys are going to learn a lot about AI as it relates to SNOMED CT. And also we hope that this is going to invigorate everyone so that we all jump on board for our entity linking challenge. So without further ado, I'd like to call up my colleague, Nick Egerhaus, who's going to give us some words for as we go into Paula's presentation.
Thanks, Susie. Hi, everyone. My name is Nick Egerhaus. I'm the Global Vendor Engagement Lead for SNOMED International and the Customer Relations Executive for the Middle East and Africa. It's my pleasure to introduce our keynote speaker today. Paula Braun was the first entrepreneur in residence at the U.S. Centers for Disease Control and Prevention. She's currently on long-term detail with the Office of the National Coordinator for Health IT. She tracks evolving health trends and helps to communicate why they matter. She has been named one of the top 50 influencers in the federal government on artificial intelligence, and she helped launch Helios, the Fire Accelerator for Public Health. She is an internationally recognized expert on interoperability and innovation, and she engages groups from across government, academia, and industry to help improve health outcomes. Please join me in welcoming Paula Braun.
How y'all doing? Great. So Nick mentioned that I was the first entrepreneur in residence, and really all that means is you can put an emoji in the title of your keynote and get it through the clearance process of not just one, but 2 federal agencies. So let's have a little fun. When we think about AI and we think about healthcare, let's get centered on why it all matters, why we're here. We do this work. We come and fly from all over the world and spend our days in these hotel rooms because we know it matters for patient care. It's not just data for the sake of data. It's not just about trying to have something perfect for the sake of some unattainable goal. It's really about that continuous learning process. And if it wasn't for the work that you all have done and continue to do, we would be much further behind the curve. Because what we're coming into now is an opportunity that had never existed before, an opportunity to take the information that's generated so that way people can be more proactive in their decision making. So that way we can have healthcare experiences that are highly collaborative and ultimately highly personalized. And standards are integral to all of this. The standards that we choose determine what we can do with the data. And so whether we're just trying to get the basic APIs so you can pull the data out, or you're doing the hard work of really getting down to the semantic layer and trying to describe what exactly does this mean, the decisions that we make along the way will determine what's easily retrievable, how it can be understood in relation to other things. So we're not just doing apples and oranges. And ultimately, so that information can be put to use to help improve people's lives and the quality of their lives and their health outcomes for the long term. I'm really proud to be here as a representative of the federal government because I think that in the United States, we have really shown a commitment to standards, particularly in the certification of health IT. And I'd like to acknowledge the work that the Office of the National Coordinator for Health IT has been doing with federal agencies across the board on making sure that the products that are out there on market adhere to basic standards and that we keep raising the bar of what we expect these products to be able to do, because it's not just about billing. It's really about making sure that this information can be used to improve people's lives. And in the latest regulation, the one that I referenced in the last slide that recently went out for public comment, it's closed now, we're processing everything. There was a shift in the nomenclature. We went from talking about clinical decision support to predictive decision support interventions. And I think that's really important because so much of what's captured over the course of clinical care is either fed into these predictive models or it becomes the point through which the predictive models get introduced into those clinical workflows. And so as part of this process, the federal government has been working with all the agencies across HHS and really an all of government approach to be able to articulate what are some of the basic things that we have to do around transparency? You know, what's some of the information that is needed to make sure that the AI is trustworthy? And how do we start to make sure that those standards are adhered to across the board? And as we continue to move forward, I'm most excited about some of the new things that are happening in AI, generative AI. You know, for a long time, artificial intelligence was used to describe things. And then as more and more compute power could be applied to the larger and larger data sets, we could then use it for prediction. And we're moving into an era where we can take all of those inputs and learn more and more information across a much broader and diverse set of data. And so these new models unleash new possibilities. So if we think about like even the most basic logistic regression that's been around for hundreds and hundreds of years, that's still very powerful. It's not going away. I think of it in terms of like layers and building the foundation, and more capabilities are coming on top of that. And so when we entered into the era of computing, that's when machine learning really came into the forefront. And you could put more and more information into there. But when you depended upon kind of linear relationships, you run into this problem of interactions, and you need to have more and more data to account for those various interactions. And what we're beginning to see is a shift in AI, where for the longest time, it was kind of like a salad. Like different slices of intelligence could provide different pieces of information. And so it's like one model, one task. That's how it had been for a while. But what we're starting to see as we move into deep learning and as we move into generative AI, the same underlying mathematical structures can learn patterns across different types of data and mixed data. And so now this ability to learn, this ability to adapt, and to be able to use kind of the same underlying structures over and over and over again is what makes this era so much more powerful and so much different from what we've encountered in the past. And I think that's exciting. And so the TLDR, too long, don't read here. We'll talk about the math behind all of this. I promise not to bore anybody with any equations, but it's about that transformer function in those neural networks. And it's those encodings and those embeddings, and particularly this concept of attention. So all that means is what pieces of the whole matrix of data stay in focus, and what pieces do you maybe not want to weigh so heavily because it might distract you or lead you towards something that's more spurious. And as mentioned before, this is really the first time that we've been able to think about image data and structured data and video data and the molecules and proteins and like three-dimensional things in the real world, and pull all of that together using the same sort of underlying constructs. And so think about the different types of relationships that you can learn when you have that underlying capability. And so some of the most important things that are happening right now are really at the frontier of that. I mean, I told myself I wasn't going to say Chat GPT in this talk, but here I am saying Chat GPT. All that does is it takes text, puts it into a linear sequence, and helps predict the next linear sequence. But there's so much more out there than text. And I was at a conference earlier this year in Chicago. You could probably guess which one. It has a big interoperability showcase. And I was walking the floor and I was trying to find, where's the diamond in the rough here? Who's doing something that's unique? And I have a little bit of a buffer whenever I'm there. I was like, okay, acronyms, buzzwords. I'm either do one of two things. I'm going to play bingo and declare victory and leave the floor, or I'm just going to kind of block it all out and then have conversations with people who aren't using those terms. And what I came across was a friend of mine. I didn't realize he had left his organization and went to another. And this is not any kind of an endorsement. This is just a conversation that happened. And I said, Ricky, what are you doing? And he said, well, I'm taking the same transformer that runs ChatGPT and I'm applying it to clinical text and billing text. I was like, you're doing what? And so we got into this conversation and these medical models. So instead of being trained on bigotry and hatred and published literature that may or may not have biases in them, if we actually start with the information that's already encoded in the medical record and with the information that's already been encoded in the billing encounters, and we think about training that underlying AI on that data, I think that's an opportunity that is really untapped. And so if we could imagine taking the GPT that runs ChatGPT and others and applying that to things like clinical notes and having that same sort of ability to do mass reasoning at scale and taking it to the work that SNOMED and LOINC and so many others, ICD, do within the medical context, and then also applying that to audio and also applying that to imaging, also applying it to the proteins and the DNA. What Ricky's done here is he's mapped out some of these major use cases and shows that if you want to be able to, for example, maybe do something around pharmacovigilance, he said these are the different types of AI models that need to kind of work together in order to solve that particular use case. And I thought it was brilliant. So I'm sharing it with you all here today. But I think what is really clear from looking at this is that most of the intention right now is being placed on institutional use cases. And I think the real frontier and the real opportunity here is to get closer to the patient and think about what it is that people need to understand what drives their health and what they can do about it in close consultation and collaboration with their care team, however they choose to define that. And so when we look at these new generative AI models, they're the first ones that were ever really widely accessible to the public. And we see what's happening. Some people are feeding very sensitive information into these models because they're finding certain things out about themselves. And that's potentially good, and it's also potentially very dangerous. And we have this tension that's growing between the medical establishment and other partners in that space and people who are just trying to navigate everyday decisions about their health. And it's not the first time this has happened. We've all heard the expression, please don't confuse your Google search results with my medical degree. And we're seeing the same kinds of things arise with the chat functionality that's available. I think there's so much more we can do with this. If we continue to think about these transformers as just another kinds of search engine, we're missing their potential. And I think one thing that I'd love this community to think through is, what if we had a different kind of navigation? What if we gave people the immediacy and the interpretation and the collaboration that they want and need, and put it on their smartphone so they could put it in their pocket and carry it around with that? Like, what if there was a combination of what Waze provides and what WebMD provides, and it was entirely focused on your health? How might that help start to change things? How could that influence the decisions you make along the continuum of care? I'm not saying it should diagnose. I'm not saying it should replace a doctor. What I'm hoping is we can get to a point where all of the information that's captured at every episode of care and all the information that people can accumulate through their gadgets and all the information that people can provide about themselves, those same forms that we fill in the United States every single time that we go to a doctor's visit. What if that could all start to be triangulated and structured longitudinally and be normalized in such a way that it could be brought to bear to feed AI, and AI could feed back a cornerstone of value that's shared by the patient and other members who are responsible for the health outcomes of that patient? And I think it's within reach. And I think the work that SNOMED and other standards development organizations are doing are very integral to this important opportunity in front of us. So if we had that better understanding, if we had that personal health navigation, it's beyond what a personal health record would offer. It's something more akin to the kinds of things that we see in the Netherlands and other places, where you can begin to layer intelligence on top of what's there. And you could begin to feed in things from your health insurance. How might that help improve your care regime? How might that help improve your quality of life? And there's a lot of momentum to build off of here, right? We have all the EHR data that in the United States, at least through 21st Century Cures Act, is largely being normalized and exposed through these APIs. And we're starting to see the same kind of things with claims data. And as we move along the continuum, there's a whole bunch of information that's at the ready. It's the fruit is ready for the ripening and for the grabbing and the picking, and bringing it together and making it understandable with AI for very particular contexts. So none of this will just happen overnight. Depending on where you are in the world, how much of investment It's already been made in your country. Just figuring out how do you ensure secure access to data is kind of a baseline level here. And of course, being able to make sure that the data are of high enough and suitable quality to be able to do things with it. And I think this is another area where advancements that are happening with our smartphones is really promising, because we can carry around a lot of information with us. And if we think about the edge computing that can happen on a simple device, and then be able to link that to certain information that could be held in the cloud, you're trying to think through how we can build the provenance around that, make sure it hasn't been tampered with, make sure nothing else, no other funny business is going on, making sure that you and the people you trust and the AI that you trust can reach into that is step one. But then I think of it as like a honeycomb, right? You're trying to generate the most amount of honey so the hives can survive, but then also that each bee can get, what it needs. And so what I see happening in the AI space is lots of institutions are kind of building AI within their walls. And that's great because it can definitely help improve patient care. And depending on how homogeneous that patient population is, that AI may or may not be useful beyond that clinical context. And so how to really think about capturing those more complex patient profiles, and how do we think about training different types of AI across that? Because at the end of the day, it's not about training AI for AI's sake to be able to say we did something cool, but it's really about helping people understand their health. And so having the actual assessments in place to be able to say, okay, based off of what we know so far about you, this is your current health status. This is how far your disease has progressed. These are the treatment options that your doctor recommends. These are the odds of success. Is there any additional information about you that would be helpful in making, this determination? And that's going to be really important for any kind of conditions where people have multimorbidities. It could be even more important for preference-sensitive conditions where the medical establishment has basically said the choice is yours. It's personal. You've got to make it up for yourself. What we give them today is maybe a pamphlet, maybe a risk calculator. I think generative AI is well positioned to help us go beyond that and to really help us think through how do we get the best care to everybody who needs it, regardless of the resources that they have or the constraints that they're under. So whatever direction we decide to go with AI, I hope that bodies like SNOMED will continue to put patients at the center of care and start to think through what information needs to be well structured and at the ready so people could have a better and more complete picture and understanding of what's happening inside their bodies. And so they can have clear action steps that will help improve their outcomes. So they can get a care plan that makes sense, that's medically sound and viable based on the reality of their life. And that they have answers, and not from something that's easily manipulated, not from something that could be weaponized against them or to be used for profit at their expense, but that can really be used to help them move forward and help the health of our populations move forward as well. And so we need immediate, insightful feedback from reliable sources. And I think that the combination of AI plus the structured standardized data that SNOMED and others are creating is an important pathway for all of us as we move into this new era. So I really just open the floor to you. What roles will standards play in AI moving forward? And conversely, what roles will AI play in the standards development community? And I hope that it's governed by the potential to help transform patients' lives, and that we're really just at the beginning of this journey. And thank you so much for listening and for the work that you're doing to help make it happen. Thank you.
Thank you, Paula. Thank you, Paula. That was absolutely great. Oh, sorry. Thank you. Thank you for that presentation. And hopefully it started to kind of set the groundwork of why it's really important to not just take the one aspect, but, really bringing in multiple aspects of the data and technology all in, and that will help us as we go forward. So we do have some time for Q&A. I know I have a tightly orchestrated, okay, great, agenda here. So we do have some mics at the tables, but also I know that we have some seating or standing room only. So I'm gonna go around. My colleague Nick is over there, and okay, go ahead.
Thank you. Nice to hear the conversation. Two things jumped out at me. One is we need to make sure this isn't done just for the sake of profit at the expense of the patient, which is a huge monumental risk in all this. And I do feel like ultimately the only way to hedge against that is to actually build these models in a kind of open source way, where as many people who can get in there and tweak and understand what they're doing and all of that are involved. Because if they're behind paywalls and they're private and they're developed by companies, they're going to be made to make money and not to help people. And the only other comment I had is, there's a really interesting thing where, you think a patient would be motivated to know the most and best information about what's good for them or what their doctor would recommend. But there's a dimension of this too, where it's like people want to know different amounts of information, and maybe the way that you present the information, you could do storytelling about similar patients and that would work better for someone, so there isn't one answer either to like how you use this to communicate and improve whatever it is you're trying to improve. I don't know the question in there, but what are your comments on those things?
No, that's great. I mean, this is discussion and question. So I agree with what you said.
Is there another question over here? I thought so.
So thank you for the thought-provoking talk. I enjoyed very much. So I like your analogy of the WAIS plus WebMD kind of combination. But my question is, even before AI, patients are frequently already looking up, their condition, their symptoms on the internet, and it's not infrequent that they come up with a whole stack of printouts when they see their doctor. So my question is, without AI, then the patient will look at the search results and can at least have some idea of how reliable the results are based on their source. For example, if it's WebMD, if it's from the Mayo Clinic, there's more reliable information, but if it's from some unknown website, then it's less likely to be true. But AI just add a whole layer over all this information, and there's no provenance provided in the results that you get from your AI tool to say, okay, where does exactly this comes from? And how then will the patient judge whether that piece of information, that piece of response from the AI is trustworthy or not? I just want to get, your comment on that.
No, it's a great point, and it's actually something we talked about pretty extensively at lunch together. The provenance is one of the most underdeveloped but most essential components of all of this. And I think there's a level of human interpretation. And so a source that I may believe is credible and valuable, others may have different opinions about that. And so I think there's a fundamental scientific integrity that we absolutely have to have as a forefront on this. And what I see as an opportunity is by having models that are trained within a medical context and making the experience that model can create available on top of existing things like patient portals, on top of other trusted sources, I hope can be a bridge toward people seeing that information is actionable when it's sound and when it makes sense to the person who has to take that action. And I think that there's a lot of information overload that's already happening. People see a lot of the same templated text over and over and over again. And if we have ways of cutting through that, kind of like what in the United States we did with the explanation of benefits, where it says, this is what your doctor billed us for, this is what we approved, this is what you owe. You know, something, even just a basic standard of information that helps to explain each health encounter in a way that people can digest it more easily, I think is a place to start, without trying to boil the whole ocean, because then at least you constrain some of the provenance and you can begin to assess the performance of these models within more of a controlled environment, and then begin to layer in some of the additional dimensions that you called out in your question, which absolutely we need to get there, and we need to maybe walk or crawl before we start to walk and run.
Thanks. Thanks for the intriguing presentation. So I have two questions, unrelated two questions. The first is, when it comes to AI, there's a ongoing discussion about, whose responsibilities. I think it started with, self-driving cars, and if it makes an accident, whose responsibility is that? Right now we have the driver. But, when it comes to AI-based medical information and patients acting upon those information, has there been any, this is not exactly information, but has there been any discussions related to whose responsibility is it to whose responsibility is it on the actions taken on those information that is provided by the model? So that's the first question. The second is, the standards evolved in the first place because the computers could not interpret contextuality and semantic interoperability, because two doctors talking with each other, they don't go into clarifying the language, but to computers talking with each other, that cannot be done. That's kind of the basis for semantic interoperability, and that standards kind of help resolve that. But now computers kind of getting the ability to interpret context based on AI. What's your take on the impact on using standards for semantic interoperability, and what would AI bring into the picture with what standards used to do for semantic interoperability? How would that interplay? How would you see that may change in the future?
Okay, I'm going to take the first question first, and then I might ask you to synthesize the second question, because I want to make sure I'm specifically answering the question that you asked. But with the first one, I think just like many other sectors, the technology outpaces the policy. And in this case, the questions around who's responsible, I think, will be determined in the legal realm. And then that's a piece of it that will just kind of continuously co-evolve and think this through. I don't have answers. I don't know anybody who does have a definitive answer to that. And I think that it's something that we as a culture and a society have to come and think through this, because it's not, if I take information that's available to me and I interpret it, am I responsible for the interpretation, or am I responsible for what was put out there? And it's an ongoing dialogue. I wish I knew the answer. And the second part, I heard different kind of thought processes in the question. And so what I think I heard was a question around semantic interoperability and the role that AI would play in helping to generate semantic interoperability. Or did I misunderstand the intent of the question?
How would it impact semantic interoperability now that computers have the ability to interpret contextuality based on the entire information that's provided to it? It may, I'm not saying it will remove the need for semantic interoperability, but it does have an impact on the computational interpretation of information for meaning. And how would you, and it may be, other clinicians might have thoughts on that. How would that interpret, or how would that change the standards role in semantic interoperability in the future, given computers can interpret context without providing, specific meanings attached to individual words?
Yeah, I think I better answer. Well, one, I think we can punt this to the panel where they might have a broader array of ideas around this. And I think there's certain laws of physics, right? You don't bet against a compiler. The compiler does what the compiler does, and it does it well when it has structured data. And so when it makes sense to go through the process of structuring something, because you're going to make really important decisions on the basis of that, then that's really mission critical. And when there's additional information that you can gather from unstructured text, you figure out how to pull it together. But I'd love to hear what some of the others who are actively working in this space, might think about that question.
I think we have time for one more question. If not, we can also move on to our video, but I don't want to hold anyone back if they have any questions or want to provide a thought or a moment. Okay.
Yes, now works. Thank you for the excellent presentation. You work for the federal government, and you already said that policy is behind on these developments. So what do you think that the role of federal government should be in this fast-paced market and space?
It's really interesting because in the last 10 years or so that I've been with government, I've seen places where policy has gotten ahead of technology and places where technology has gotten ahead of policy. So I don't think it's necessarily a static state. The role of government is the role of everybody in the populace that elects the government. So I don't think it's not necessarily that a certain legislative body has to do one thing in particular. I think as a society, there are real risks around AI, and it's evolving at a pace that's much faster than what most people can understand. And I think, how do we begin to understand those risks? How do we think about exposure to those risks? How do we think about the severity of those risks? How do we think about real things like enfeeblement? How do we think about Trojan horses that might be implanted? How do we think about all of this? And it's not a one particular body's responsibility. I think as a society, we all will benefit when we're all more informed about it. And then we all take proactive steps in our own lives to understand its influence and be as educated as we can, and to be as intentional as we can, and to just practice the Hippocratic oath of first do no harm.
Thank you, Paula. Can we give another round of applause to Paula? Okay, and next we're going to have a short little video.
Doctors and nurses who use AI will replace doctors and nurses who don't.
Good day, and welcome to this very special episode of HIMSS TV. I'm Bill Sawicki, Managing Editor of Healthcare IT News, a HIMSS Media publication. Today, I have a very special guest, one of the most important and venerable voices in the healthcare information technology industry, Dr. John D. Halamka. He is a medical doctor who holds a master's degree in medical informatics from Harvard. His long and impressive resume led him to his current job, president of the Mayo Clinic platform. I've interviewed him from time to time over the last 35 years, and it's a privilege to have him here today. Welcome, John.
And a thrill to be here. Isn't it wonderful that we started talking when we were both 4 years old?
I think my Johnny Carson white hair belies that age. But yes, I agree. The topic today is artificial intelligence. from John's vantage point, I have a number of questions. So let's jump right in. First, John, is AI in general evolving faster than you thought it would?
So as you say, we've been chatting for 30 some years. Remember in the 1990s, as I worked on AI, it used a technology called forward chaining. You would write a set of rules, like a mammal raises its young and gives them milk, right? You'd write a set of rules. Those rules were static. They were written by experts, and then they would take months and months to create, and they were obsolete the second you created them. Well, then we went on to things like logistic regression and Bayesian analysis. All of this was very slow for decades. And then we hit convolutional neural networks and things started to speed up. Well, now, as you see with generative AI, go look at the Hugging Face leaderboard. You will see the leading generative AI changes every day. So the speed at which we are innovating because of large data collections, large amount of compute, and rapidly evolving tools is dizzying.
Yeah, you can't go a day without another development. It's amazing. What is the promise and what are the risks of generative AI in healthcare?
So let's step back and look at predictive and prescriptive AI. The idea is, hey, Bill, do you have a disease? Will you have a disease? If you do, what do we do about it? Those kinds of AI, you can measure ground truth, right? A set of inputs, a set of outputs. What actually happened? Did they work? Did they not? Generative AI, a very different beast because it's not deterministic, it's probabilistic, and really all it's doing is predicting the next word in a sentence. Every time you write a prompt, you're going to get a subtly different answer. So how do you assess quality and accuracy when every time you use it, it's different? I could argue that AI of all kinds needs to have transparency. How was it created? It needs to have a sense of consistency. That is, every time I use it, it's going to give a sort of reasonable result, and reliability, that I actually feel like I can use this for a given context. So I think where we are with generative AI is it's not transparent, it's not consistent, and it's not reliable yet. So we have to be a little bit careful with the use cases we choose. So that is, if I were to say, hey, generative AI, I get 1,500 emails a day, could you pre-draft email responses? I'll edit them and then send them. That's pretty low risk and actually very likely to reduce my burden. If I say generative AI, Bill's got chest pain right now, what is it? That's really likely to do harm. So I think we just look at use cases, look at outcomes, and the next few months, we're going to learn so much from each other about what to do and how to reduce some of the risks.
And on another note, the Mayo Clinic CIO, Chris Ross, has spoken often of big AI being clinical decision support models and little AI, things like process automation. How is Mayo approaching both?
So what's interesting is I absolutely everything Chris has said in the past has been true. I'm actually starting to see blurring of what is big, what is little. And so let me just give you a general strategy as to how Mayo is approaching some of these things. On the predictive side, we have 184 models that we have built. We just did an inventory across cardiology, neurology, behavioral health, radiology. 18 are in clinical production every day. 35 are in clinical trials and research. So what you start to see is on the predictive side, there's a gap. Everybody has it between the models you build and those actually in workflow being adopted by physicians every day. So for one of our first steps is to increase the number of models used in production at Mayo and its affiliates. And we're working on that. On the generative side, as I was getting at, there are so many strategies. One strategy, it's bold, is you could build your own foundational model. Because today's foundational models are built on the content of the internet, and therefore their likelihood of hallucination pretty high, right? They don't understand medicine so well. Think of them as the world's smartest high school student. So would it be better if you started from scratch and healthcare organization trained a foundational model yourself? Could cost millions of dollars, but you'd have really tight control of content. Okay, you might want to do that. Or might you want to partner with an existing proprietary model and do additional pre-training on healthcare data and fine-tuning with what we'll call instruction sets, that is, questions to ask, answers to expect, have humans through reinforcement learning with human feedback, help get to better and better answers. Oh, well, that might work. Then, of course, there's another technique, retrieval augmented generation. You don't trust Reddit, but do you trust Mayo Clinic? Do you trust Cleveland Clinic? Do you trust HIMSS? Oh, yeah, those sound like credible organizations. Well, if you say, I'm going to go out to the credible sources of truth and then ask generative AI to summarize those couple of credible sources of truth, it's likely to actually do a pretty good job. So Mayo is going to do all of these things and report to the world what we learned along the way, because it's just truly not clear at the moment who the winners and losers will be.
So as you can see, we're really starting to set those foundations as we start to explore how and where AI and SNOMED meet. Also, we're starting to define what is the difference between predictive, generative AI, and other informatics tooling. And so what we hope to continue some of that discussion, we have a panel discussion today. Come on up, please. Again, and that discussion will be entitled SNOMED CT and the Role of Terminologies. So today we have moderating Will Hardman. Will has spent 20 years as a practicing data scientist, working across a wide range of public and private sector organizations. In 2011, he co-founded a specialist data science consultancy, which grew to support several large-scale healthcare data programs in the UK and US. As an early adopter of generative AI technologies, Will now focuses on helping organizations understand how to understand and exploit these technologies in a world where the hype can often obscure the reality. We're also joined on our panel. Are you guys scared? Come on up, guys. Come on. Or did you want me to like have some drum rolls and you guys can go on? They're just scared to do anything not on my script. So we have Dr. Anthony Scheck. Anthony is a lead NLP engineer at Guy's and St. Thomas's Hospital in London, where he spearheads the development and implementation of AI-based NLP terminologies. He advises on the deployment of large language models in multiple hospitals across the UK, US-centric, and internationally. Anthony holds a PhD in clinical neuroscience titled AI and the Sacred Disease. Beyond this, his groundbreaking work includes the collaboration with NVIDIA to create the NHS large language model on the UK's fastest supercomputer, showcasing his commitment to advancing AI in healthcare. We also have Igor Kuto. Igor is the leading technologist and social entrepreneur valued by top organizations for expertise in mission-critical systems and transformative impact. Specializing in digital economy, agile frameworks, and smart systems. He's the co-founder of OneST, a deep tech firm, and the Deep Tech Network. He's a key influencer in the technology realm. He also co-founded ViaWeb, a global initiative nurturing IT talent from disadvantaged backgrounds. Currently, he is the CEO of SOFA, a bioinformatics startup developing reliable, explainable AI for clinical use. And last but not least, we have my dear friend and colleague, Dr. Christian Rake. Christian is the CEO of Odysseus Data Science Services, a real-world evidence company based on the Odyssey approach. He is also professor of practice at the Roux Institute at Northeastern University, where he is responsible for the Odyssey Center and Real-World Master's Program, and he's the principal investigator at Odyssey, an open source and open science collaborative generating comprehensive evidence about disease, healthcare delivery, and effects of medical interventions through large-scale analytics. And no conflict, but major collaborator with SNOMED International as well. He was a practicing physician in Germany before moving to European bioinformatics research to work on the Human Genome Project. And he has had various positions in biotech, pharma, and CROs on typical challenges in drug research and development, such as gene sequencing, expression analysis, and clinical trial designs. He is a MD and has a doctorate from Medical University of Lübeck. And without further ado, call Will up to the lectern.
Thank you, Susan. I feel like with the 3 seats there and me standing, it feels a bit like less a panel discussion, more like a panel quiz show. So you put your fingers on the edge of your seats with buzzers. So I've worked in data science and AI for my whole career, and been following the development of deep learning, neural networks, transformer models throughout that. And there's been a really profound change in the last, I'd say, year or two. And that is that when I go to parties, people now want to talk about what I want to do for a living. So that's been great, but really it's generative AI is the thing that's permeated the public consciousness. And that's why everyone wants to talk about it. And so today I thought it was a great opportunity for us to have sort of 3 people who really know this space sitting here, and we can explore a bit more about, firstly, what is generative AI and why is it different to what came before? But also, what opportunities does that create in the healthcare space, and what challenges remain in front? And finally, what does it mean for an organization like SNOMED, and what does it mean for terminologies into the future? So I've got a bunch of questions here. I'm going to start with Anthony. Could you say a few words maybe about what generative AI is, and is it sufficiently different to the models we might have seen 3, 4, 5 years ago?
Right. Yeah. So basically, what generative AI is that a lot of these computers are really good at pattern recognition. And what generative AI is, what we call nowadays, is that when we have a new data set, can we use the compute to generate new patterns, or not essentially new, but learn from old data sets and apply it to new foreseen and mix up the jigsaw puzzles together. And so it's not really, I would say it's not really new in the frame of in the bigger scheme of things. Is that when it's just recently with the advent of ChatGPT or OpenAI, I think the public has really seen the larger progression, and they're getting exposed to it, and so that's why it's built a lot of hype. And the whole idea of AI being, this is what AI, or what people have in their heads of what AI is something that is generative. That's not necessarily the case, but that is what's happening at the moment.
Yeah, would either of the other of you add anything to that?
Well, I think that generative AI represents a new generation of AI, a new kind of technology that can show signs of some cognitive capacity. Instead of just providing the answer, the technology first can figure out which of the steps it can need to execute before answering something. And the knowledge base that generative AI is trained is giant. It's basically near almost of our knowledge in the world that's publicly available in the internet. So the attention module and the transformer capacity is really, really powerful. So now we had the opportunity to have in a limited subset, like our brain works. Before moving a chair, we take a look and see if it's possible to move that chair, if that chair has something in top of it, and how long will I stay the chair in my hand. So we figure out the task before executing. And generative AI in many contexts can do that, can figure out what needs to be done before providing the answer. And we are exploring that technology to provide some reasoning capacity to human beings.
Yeah, so there's some qualitative differences in generative AI models. It's not just about learning to predict a target or learning to classify an image. It's actually, but they can actually do things. They can reason about the world, and they're genuinely open-ended capabilities in the models. So given that then, Igor, have you seen any applications in healthcare for generative AI? Something that might already be going on, or maybe something you anticipate happening in the future?
I think that's important for us to remember the why why we need the amplification of human beings with that technology. If you look at the situation of healthcare workers, if you look at the burnout statistics, we will find that more than a half of healthcare workers show active signs of burnout. If we look at the administrative burden and the digital bureaucracy, we'll find that more than a third of the time we waste filling papers, filling forms, providing information that we already have. So we are stressing our professionals with inefficiency. So this is the first why. And of course, the cost can be seen not in our medical bills, but also in medical errors. So we have a lot of ground for improvement, and the healthcare professionals are literally screaming for help, and the technology can help them. So I think I can summarize in 3 points, like generative AI would do. It's to finally solve huge systemic inefficiencies, not only in the payroll side between the payers and interoperability, but also in the clinical workflows. We can now solve that inefficiencies. To really personalize care, because AI can access giant amounts of data and has all of the computing power, much more than our brains in some sense. So we can really personalize care with the most up-to-date scientific research, with the most up-to-date clinical trials. So we can have another layer of personalization, and also to enable the dream of precision medicine, because we can join data, we can join clinical data, we can join epigenetical data, we can join genomic exams, and also social determinants of health, and build more integral algorithms to analyze each individual. So what I see is not only AI being in the direction of efficiency, but also personalization and precision.
Yeah, anything to add?
That is very, very true. The difference that we, or the fact that we all think that we are on the cusp of something new, of course, is the fact that now these models have a gigantic quantity, and from the gigantic quantity follows a new quality. So if you play with GPT, we're going to use that term, probably a lot in this debate. It's like, you know, it's never as good as the real top expert, but it's a ton of experts all the time. They are ready to answer the question in no time. So that's a completely new quality that we can now apply, which we couldn't before. Before it was always in one-off job. Polamka said the same thing. While now the thing's sitting there waiting and having a whole lot already figured out or modeled. And that can help us in the process, in the execution of healthcare, in patient care directly. What's the right choice? Also, Paula gave a lot of good examples for that. But also in the ability to gain understanding from large scale. Because you said it, every doctor sees only so many cases in their lives and draws the conclusions in their own little neuronal network in their heads. While this thing, of course, can do it with over hundreds of thousands and millions and patients and draw much better conclusions and then make it available. So again, this is a flip from a really a quantity into a new quality. And I don't think we all know, we can like dream up all the applications that there could be, but we're going to learn a lot what works and what doesn't work.
Fantastic. And I think it all fundamentally stems from the fact that there are just so many patterns in healthcare. And so whether it's from automating the boring stuff, administrative tasks, or it is with diseases in general, the doctors call this experience, but AI can learn from all these patterns by looking at all the patients that have ever visited a hospital or across the country or across the world, and can then use that knowledge, amalgamate it to find common patterns and apply it to an individual and personalize it that way.
Yeah, absolutely. Thank you. So we've got use cases around clinician burnout, we've got use cases around clinical decision support, and we've got use cases around retrieval and assimilating research, huge quantities of research. So there are clearly opportunities, but I guess there are going to be challenges as well. Getting an AI into clinical practice is going to be hard. There are going to be barriers to overcome. So I'm wondering whether any of the three of you can think about what those barriers might be, or maybe you've actually got experience of having seen AI trying to get into practice and what the challenges have been.
Fantastic. So yeah, I do that for my everyday living. And so working with healthcare, you're working with a lot of, I mean, in the UK anyway, we're working with a lot of legacy IT infrastructure, things that were procured 10 or 15 years ago. And so what happens then is data is scattered and often siloed and not well connected. And so just getting access to data, even from within an organization, let alone if you come from a commercial company outside, because health data is very sensitive and very personal, and you can't really share. So one, it's really just getting over that hurdle just to get access to the data. So that's key point number one. Second one is, of course, you're dealing with very sensitive and private data. And so it needs to be handled with a duty of care and responsibly. And actually, we do find that if you de-identify and clean up a lot of the free text records, you actually get better results from your AI models or algorithms, whichever you're applying on. It just simply because that a lot of disease names are named after people as well. So whether it's Parkinson's, Alzheimer's, or Lou Gehrig's disease, for example. So there's not ever an excuse to never de-identify it. That's different to anonymize it, where you lose all forms of redaction, but at least the basic steps of pre-processing should always be done, in my opinion. And I guess lastly, compute. Of course, compute is a very important factor where big tech has multi-million pounds of compute available, GPUs, which can take advantage of which the latest architectures of these AI models can take advantage of. Hospitals, which are limited in funding, often don't have that kind of compute. And so alternative strategies need to be formed. So there's limitations, in my opinion.
Well, I would like to start with Anthony's point that you need to make your data ready for AI, because your AI module can be perfect, your algorithm can be precise, but if your data is ambiguous or can lead some misinterpretation, the start of the intelligence pipeline is broken. So this not means to structure everything, but you need to have clear guidelines to prepare data for AI, to be secure, to be more understandable. This is the first one. The second one, I think, is the risk of what we call magic boxes. Let's think about the large language models as some magical that you give a prompt and they send a result. They are so powerful, but they are risky. They will improve the precision in the upcoming months and years, of course, but they will bring up new problems also. So we expect them to reduce the hallucination rates, but they will create another challenges. So we need to acknowledge the dangers of the magic box. And the third one is to acknowledge also the importance of clinical decision support standards. This is a challenge because the clinical decision support standards are complex. And we are dealing with the complexity of data, we are dealing with the complexity of the risks, and we need to be adherent to strict rules for clinical decision support. So I think that those three challenges marks the start of the question. And the second one for me is the most important, is collaboration. Because of course I'm a technologist, I'm worked with hospitals every day for years, but I can't understand medicine. I'm not a doctor. I believe that AI should be developed and deployed by healthcare professionals that are on the field. So how can we transform physicians and nurses and every healthcare professional, not only in allies, but as leaders? Because as a technology, it's easier for me to have in a direction, to think about or to design and build AI engines with a clear direction. So developing a deeper form of collaboration with healthcare professionals for me is the most important challenge right now. And we need to be better at explain the technology and the capacities for the healthcare professionals.
The first time I hear a CEO of a technology company be that humble and not say, oh, you can do it better, we're going to disrupt and throw all this old bullshit away. Very nice. I mean, the fundamental problem, which all these, so you were talking about most of the input. You were also talking about the input and the problem with that. But the big problem is whatever these systems do is they give us a probability or probabilistic answer. Okay. And rarely do they tell us what the true probability is. Particularly GPT loves to just, it's like knows everything and talks like it knows everything. And if you say, "Are you sure?" it says, "Oh no, I'm not sure. I changed my mind." But it's funny. But of course, that is actually the core of the problem. We naturally expect that the technology of computers will give us maybe dumb answers, but always correct answers. Okay, database. If it works, you get the right thing back. Otherwise, it's a bug. Here, it's not a bug. It's part of, it's a feature. It's part of how it works. So we have to learn to deal with that. It's funny that we have a hard time dealing with that because it's not like the doctors always make no mistakes and know everything and don't very confidently make a stance. And it turns out, well, that wasn't quite right. Or any other humans for that matter. But there we found a way to deal with that. Systematic institutions of learning or comparisons or benchmarking or publicity or something like this. So we found a way to deal with the fact that people may say something that may not quite right, and they may know that or may not know that. And so we need to teach the system to say, this one, I need to really have you confident. Don't tell me otherwise, okay? Because this one matters. That one doesn't matter. This one, whether I should open the right or the left knee to do a procedure, I should be really sure. And so, and we are not there yet. We are learning, and the society has to wrap their head around that.
Yeah, thank you. So we've kind of got three big pillars or three big challenges that you were kind of exploring there. I mean, there's about collaboration, the importance of collaboration, the fact that we're dealing with fundamentally probabilistic models. And so there's a lot of work going on at the moment about, okay, how can we control the generation of the models such that we reduce the likelihood that they're going to produce outputs that are erroneous? And I guess the tradition of the classic is data. So when I started work nearly 20 years ago, we were building business intelligence applications for people, and people would say, "I want this report," and everyone, and the response would always be, "You need to sort the data out." And 20 years later, working in AI, people are saying, "I want this retrieval augmented generation," and we say, "You need to sort your data out." So it's exactly the same. And I guess this prompted a question in my mind, which is that lots of the world's healthcare data is unstructured at the moment. And of course, it takes a hell of a lot of effort to sort of annotate or clean or label or classify data. Is it actually still worthwhile doing in the era of generative AI? Or should we just wait for an AI model to interpret it all for us?
Wait, did you want to speak? Yeah, so we have a system in London where we, I guess, structured the unstructured, a tool called SNOMED that although we can do a lot of it automatically, it's certainly not perfect. The key part is that technology is going to change and evolve. We've seen this with everyone's been following the rapid rise of the GPT models and transformers, and there seems to be a new model being released every week and a new multi-billion-dollar company being created. But what's key is the way how we validate and we standardize and structure what these outputs should do, and to create these benchmarks when a new model comes, or when you take a model from the UK or from Thailand or from China, if we have a human validated or a gold standard, then we can really have something to compare it to. And that's something that would always need to be the case, something that clinicians need to do, one, as part of an engagement tool to help interact more with models, and two, as well, to keep up with the ever-changing medical guidelines and guidance and methods of practice, because medicine isn't a static process, it's constantly changing and evolving as well. And so it's a dynamic process that's in a way, you're never going to replace the human annotators. They're just going to become I guess, validators or model validator. So that's what my opinion is, but I don't know if anyone else has others.
I mean, so in the one-off case, patient care, if a doctor, for example, a nurse, interacts with the facts about a patient and makes decisions, okay? It doesn't matter that much of whether the information is given in structured form or in text form, because they have a little neural network built in, and they can read either one. In fact, both of them are presented in a similar fashion to them. And that's just okay, because that's how we operate. The problems start if we want to do statistics, which these models don't do. I mean, they do, but they only do the one statistic that they're built in. And then we need facts that we can count and calculate and compute with at scale. And so immediately you die if you want to ask a question like, of all the patients who had 2 COVID vaccines, how many of them had a breakthrough infection? And then start reading every patient's chart text, then no matter how much compute power you throw at that, it's going to take a couple of months. So we will need whatever methods and whatever statistical approach these probabilistic models have. That's not enough to answer all the questions. Also, it's not enough because we also need some logical reasoning, okay, which they're also not necessarily are built for. Like, turns out that sometimes their methods, their probabilities come out right, but if it becomes very complicated, of course, they die. And so same thing, for those we need the facts. So without clearly defined facts, which are also have some semantic foundation of what they actually constitute, we can't just give up and say, oh, we're done. That thing can, we can go home. That thing can take over. There's a lot more that needs to be done.
And I believe that generative AI open up a new whole level of possibility about structuring data that's using natural language inferences, that once you define the safety fences about data and the boxes that you want the new generative AI to fill in, and you are somewhat specific at the context, the new generative AI are pretty accurate at classifying data, at structuring data, because the very own architecture of the transformer is pretty good at it. So finding the right level of structure, you can leverage generative AI modules at scale at a very affordable cost to have a new level of data classification. And you can also make what we call multidimensional data structuring. I want to structure that data in FHIR. I want to structure that data for observational life science in a longitudinal way. I want to structure that data for transactional between parent providers. So you can structure in many ways, leveraging natural language inferences. We have some experience in doing that in some specialties in Brazil. So it has a really, really good accuracy in natural language inference in a very delimited scope of data structuring.
Cool, thank you. So 2 things really came out quite clearly from your answers there. The importance of facts and the importance of that facts play in healthcare analytics, and the importance of structure, placing structure on your data. And of course, one way of thinking about SNOMED CT is essentially a big box of facts, true facts about healthcare. So I guess one question I have is, are any of the research groups building generative AI models or using their generative AI models actually thinking about how they can use the power of a terminology like SNOMED CT to make the models better? Maybe to Anthony first.
Oh, I seem to get all the questions first. But I guess just tying back really quickly, maybe it's a bit more of a philosophical question, and we can go into this debate a little bit. But what is a fact? Because I guess even with SNOMED CT, there's areas, and even SNOMED CT is constantly changing according with changing medical guidance. The nomenclature of diseases and disorders are constantly changing the more we understand about them. when a new drug is discovered, maybe clinical practice changes as well. And so with the problem with, I guess, with a lot of these generative AI models, they have been trained on historical data. Sure, they may be able to then apply it in something that looks very new, but fundamentally, if you trained it on a data set pre-COVID, it's not going to know what COVID is, or the word that we would give it. Maybe I'd be able to describe it as a infectious disorder that infects the lungs, but to give the name, that's something that us humans decided on. And so that's why I think there's always a place for SNOMED CT. Sure, you can use AI models where it is generative to help define and classify these areas of knowledge. And that's what SNOMED CT to me really should be, is that there is a code or a representation for each domain or area where you would then, whether it's interoperable with human machine, other humans, or machine to machine, that's really the true power of SNOMED CT. And so, yeah, whether you can use these tools to enhance it, discover new ones, help with the mapping as well between different areas, whether it's drugs and brand names to drugs, or even relationships between different disorders. So there can be all sorts of patterns built there. So yeah, did that answer the question? I feel like I went on a bit of a tangent.
No, I think so. It's good.
Okay. I believe that SNOMED plays a crucial role being the semantic layer. There's a metaphor. If you heard some two IT guys talking, they're using tech language. Two pilots talking, they're using like airline or aviation language. So we need to transform the large language module's natural language into medical language. And that's the point that the semantic layer, the terminology plays. So we can convert unstructured data into medical language to apply medical knowledge. So this is what we are doing. We are processing the data, not only for classification, but also for transform. We can apply summarization. We can apply the new technologies to transform data to medical language and then apply medical knowledge. And also another important part that I saw in the video, that we have now a new horizon of opportunities to craft more intelligent rules. Because before it was like a week, a month to develop some rule set, some library of rules. But once you get that medical language and that medical knowledge using retrieval augmented generation, you can have more deeper rules, more complex rules that were written by the generative AI. And that's the point. The human can review the rules, can tweak the rules a little bit, but the generative AI can even, we're trying that past week, read an article, try to identify the most important logic parts of some article and propose rules based in some paper or scientific research about some field. So we will now can enable deeper rules processing because we have data more structured and also medical knowledge in also the same medical language. So we are enabling a new level of logic for the computing systems.
And I guess just to I guess point out the fact that there's lots of big tech companies out there. There's Google just down the road from here. They've created their own medical generative AI model, MedPalm, and I'm sure the other big techs have produced the same as well. But there's a reason why they're not in hospitals quite yet. And I think they'll piece on that. They need something like SNOMED to really be that layer of interoperability, to classify a knowledge that is directed or validated by humans as well. So I think the real key question is, we discussed that, yes, SNOMED or something like a terminology structure like SNOMED is highly valuable. I think the key question that we should all be asking ourselves, or SNOMED especially, is that I guess there is an opportunity for potential partnership or collaboration, and to align between the big techs and the way how we define and represent clinical knowledge here. Yeah.
Small text too.
Yeah, small text too.
Yes, small text also.
Yeah, thank you. So that's some insights into maybe the importance of a terminology for example, the communication or the semantic layer that sits underneath or is used by a generative AI model. What about on the kind of clinical safety side? That's already come up again today. Is there a role for SNOMED CT, for example, in assuring that a generative AI model is producing safe and accurate results? Maybe to Igor.
Yes, this is something I believe that the core part of the decision support should not be made in a statistically based language, because it can hallucinate, it can be wrong, and an error might be catastrophic to a patient. So for me, the core of the reasoning should be made into formal language. So you can use generative AI in the beginning to structure data, to make low risk inferences, to prepare the reasoning process. And you can also use generative AI to augment the reasoning, to look for scientific papers, to summarize some articles or sources of information. But the part that does the reasoning should use, in our instance, we use clinical quality language. You can use SNOMED, ELM. You can use a rules-based language that is reliable. This is something architecturally important, in my opinion. So I used it to work at an airline company. My first job was in an airline company making systems for aircrafts. And when something bad happens, and something bad happens all the time, the first thing the pilot makes is to get the manual and to follow exactly the rules. And this is why aviation is so safe. So I really believe that the core of the model should be formal and computable, and not inferable or using some magic box to do the diagnosis for a patient.
Yeah, but I think that's correct. That's a good example. These language, so there's AI and there are the language models. Right now we are jumping a little bit back and forth. The language models are language models. So they read a lot and kind of like get it, just to use that term, okay? But a lot of the knowledge has to be first produced for it to read it or to capture it, okay? It cannot do that. It cannot run a statistic. It cannot run in a formal logical chain. It can do that if there's text that underlies that, and it can like draw all sorts of correlations and patterns out of it. But if it's not there, it's not there. And so we haven't just quite yet given up good old-fashioned methods to generate the knowledge and then turn them into fixed rules. And for that, of course, we need semantic concepts, clear facts that we can state and that we can prove. And again, Holamka said it, you can't actually run a recall or precision on any of these generative models, but you can do that very well on other methods, conventional methods of knowledge generation. And so we will need it. We will need for something like SNOMED to be the connector, okay? Here are the entities that I want to be talking about precisely, and not some wishy-washy talk that you can then change in the next, when you click regenerate. And in order for us to actually precisely generate this evidence and disseminate this evidence in textual form, so it can pick it up and do all sorts of good things with it.
Yeah, thank you. So a few minutes ago, you were talking about the importance of a semantic layer and with generative AI models, and now we're talking about kind of the importance of not ditching kind of formal rules-based approaches, but augmenting them with the capabilities that language models bring. And the theme of probabilities has come up a few times as well, and the fact that, for example, a GPT-4 will quite happily give you a SNOMED code which may not exist, which tells us that it does know a lot about SNOMED, but it doesn't know everything about it. And so I'm curious, I genuinely don't know the answer to this, but at what point in the future does a GPT 2030 fully understand SNOMED CT, or does that not happen? Or if it is going to happen, what's going to make it fully understand it?
Okay, I can go first. Let's keep this theme going.
Okay.
So having a large language model memorize SNOMED CT is completely the wrong approach. It should not be, it's an external data set, external set that keeps on evolving. It's a evolving terminology or dictionary. And so, having to retrain and then redeploy it everywhere, it's crazy. So fundamentally what organizations do is that you have a foundation model, a large language model, which you can then chain certain actions to it. And one of them is, I guess, each of these actions are called what we call agents in the field, where you have a large language foundation model that is good enough to read a bit of English. And then so you have essentially, let's call it ChatGPT in this case. You have the second part of the chain that says, okay, to answer this question, you need to look up SNOMED CT, this current version. And so that's what we call an agent, something that's exposed to the external environment and that can come back and retrieve that it's from this data set, you can read English, read SNOMED CT and retrieve the right code and attach it. And so you have this almost series of thoughts that would be the way forward, because I guess training a large language model costs millions of pounds, and it's not building, I think we're past the age of building bigger, more complicated models. I think it's starting to get to a point where we're building an ensemble of models, or a spine or a structure where we're interchanging various parts. Yeah, and I guess that's what ChatGPT kind of is, where you have a sort of reinforcement with human feedback layer on top and a privacy or protection layer as well. So yeah, I think that's how I would answer it. Yeah, it's not really a large language model's responsibility to learn SNOMED.
Yeah, it's a good answer. I asked the question, will it? And I should ask the question, should it?
Yeah.
Should it learn SNOMED CT?
No, I guess it's my answer, short.
Well, actually, I'm surprised when it hallucinates on SNOMED, which it loves to do. What it does is it comes up with concept IDs, have the right size, like whatever, say 8 digits or something, and then a name. The name looks good. This thing should be a SNOMED concept, but it isn't. What that tells me is what it actually does. It does what people in this room do, which is infer from the generally existing knowledge, which of course is in text and in our minds and our little neuronal networks, and somehow extract what are the core facts and principles and concepts and the hierarchy and the relationships. And it thinks it can do that too, and no, but it sometimes, it's impressive how it does it. So maybe the question is not, should it learn SNOMED, but the question is, should it help make SNOMED, and in the process, then maybe also learn it, because it just made it. And maybe that's because that is the process which it can much better emulate than the process of using them, finding the agents, finding them, and then using them for logical computations. Maybe that's where its strength actually lies.
And something I invite everyone to think, the AI not just as a module, but more like an engine with many parts, and an engine that you can design to be powerful, to be safe, to be unexplainable. So I believe that the foundational modules are like the first parts of this engine. You will have specialized modules, like the ones for terminologies, and also the intelligent agents in top of specialized modules that can reason and adapt the AI to each specific case. So thinking more like an engine that we can design, we can deploy, we can enhance instead of just one module. And that's some important thing for me. And another one is the importance of process, because we look at AI only at the technological part, but the process of building the AI, it's many times more important than technology itself. So when you are applying a medical terminology, a semantic layer, when you are putting SNOMED in top of a large language module, you are not putting codes. You are putting governance, you are putting knowledge, you are putting experience, You are putting safeness in top of your module, because SNOMED has a really nice governance process. So also I invite everyone to think as an engine, but also a process that builds that engine that can be better or worse.
Cool. Yeah, thank you. So as we start to move towards the end of this conversation, maybe you could take it in turn and tell the audience, what are you excited about when it comes to generative AI in healthcare? What do you want to happen in, say, the next 2 years, and what should we be looking out for?
When I start that?
What I'd like to see in 2 years, cure cancer. Why don't we start with that? That'd be great. But I think realistically, that's not gonna, well, I mean, hopefully be the case, but realistically, I think with a lot of the generative AI, we can help automate a lot of the, automate away a lot of the boring or administrative burdens on the everyday healthcare professional. We can open up a new avenue of, I guess, research and explore new potential biomarkers of diseases by, I guess, essentially interpreting big data at scale. And yeah, and I guess lastly, forecasting. With generative AI, it's all about generating the next series of text. And you can really, we're looking at health patterns or health trajectories. It's essentially a sequence of, SNOMED tokens, if you want to look at it that way. A patient disease, you have diabetes, you then have diabetic retinopathy or diabetic foot or complications of diabetes. And so why not apply that same process for language? That was what ChatGPT and all these large language models do, but for this series of sequence of SNOMED CT concepts where you can then start predicting diseases. And I think that realm will get very interesting.
Well, I dream with the democratization of quality care, because once you get the leading experts at some field and build like the better algorithm in the world for that specialty, you can immediately scale that algorithm basically to everyone. Once you get scientific validation, once you pass through the process to get that AI and run for a patient or 1,000 of patients and 1 million of patients, the cost is marginal. So I do expect the opportunity to democratize quality health for everyone. We're working in one case, just for instance, to materialize, where 5 of the top allergists in the country in Brazil are researching an algorithm for anaphylaxis. And we are getting scientific validation about the data set, about every language differences in the country that makes the anaphylaxis diagnosis. But once we get to that algorithm, we can scale to the population immediately. Once we get that level of power and also safeness of that algorithm. So we can scale quality care really, really, really fast.
That's interesting. I think the democratization would entice me as well. There are clearly concrete examples like this, but I would take it generally, right? So what it can do is to bridge the gap between the knowledge that we have and people who have to get to the knowledge and apply it to make decisions. And it's hard today. You have WebMD, so if you want to know something about a disease, you have to read, and oh my God. And I'm thinking, should I use WebMD or Wikipedia or so? And I have to read through a whole lot of text until I come to the point that I'm actually looking for. With GPT, I don't have to, I can just ask it. And everybody can do that. So democratization of knowledge, that it's not only anymore the privilege of some people, well, who have spent a lot of their time and money sometimes to get to that point, but to actually spread it to mankind. That's where I see the biggest impact. And you can build lots of APIs. So right now it's just one website, but you can put that thing onto, patient chart systems, and you can do all these ideas which we talked about, applications that would help, or that Paula showed us, that would help with making it easier for people actually to apply what's already known, but today they can't get to it.
Yeah, thank you very much. So, thank you very much for your time today, guys. For me, it's been a great experience because although I talk a lot about AI to people all the time, I've had a chance to actually write down sort of a dozen or so questions and then ask people who do it day in, day out, and are in the weeds of working with it to get some real insight, which is fantastic. So thank you for everything you've shared with the room. How do we do for time, Susie? Fantastic. So yeah, we have time for questions. How long do we have? 15 minutes, brilliant. Okay.
Thank you for the thank you for the very exciting discussion. And I have a specific question about Odyssey for Christian. So Odyssey, the Odyssey Consortium, I think, has arguably the biggest collection of patient data. And I wonder whether there has been any thought about making use of that to train a large medical model, like using techniques like distributed training to benefit this whole field. I mean, that's my first question. And the second question is about, I mean, there's been talks about whether what SNOMED's added value would be in AI and model training. I think that can be tested as actually in the Odyssey environment, because you make use of SNOMED, I mean, as a standard reference terminology. And it would be interesting to see what the performance of the resulting model would be with and without using SNOMED. I think that would be a nice ablation exercise. I mean, I wonder whether that is feasible or not. And
yeah, sure. So I don't know if everybody knows what Odyssey is. It's spelled OHDSI, odyssey.org. And it's a large open source, open science collaborative. And there are lots of people, and some of them have data. So they're like over 500 data assets who have all the data in the same standard. And the standard uses SNOMED as one of the, no, for certain domains, for example, conditions, it uses SNOMED as a standard to represent the data. I know people start doing that. They're saying, hey, can't we just train on the data directly? Why do all the statistical methods and this epidemiology, and it's just toss it onto a large model and see, maybe it can figure out some trends, some facts, some evidence. And people know that, and I'm sure that people know that I don't know about, do it too. And we'll see. It's too early to tell. Obviously, it's a little tricky because you can't just upload it to OpenAI because it's patient data. But there are ways to figure that out. I'm a little bit skeptical because it's not language. It's a very, very dizzying aggregation of individual facts. And you have to be able to tease out the relationships between them. And the relationships are wicked because everything is connected to everything. So you have to have a machinery to do that. Whether or not these transformative methods can deal with that or not, I don't know. But it isn't text. These patient data aren't text. And second question again, King.
But I mean, I think the data, of course, are coded primarily, but they can be converted to text, converted back to text, right? So it's no different from a big corpus of text with timestamps and all that, right? Sequences. I think it's doable. I mean, but of course, I'm no expert. So my second question is related to the role of SNOMED, whether a nice comparison would be to do with and without the help of SNOMED, what the outcome would be.
So you can turn patient data into text, that's correct. It's very boring because on day so-and-so, a visit happened, and at the visit, this was measured, and this was a diagnosis. There's no conclusions or inferences in the text. It's just fact. And whether or not these facts mean something or not, I do not know. Whether these methods can pull it out. Maybe you guys have a better understanding or better sense for whether this is, whether we should be optimistic or not. SNOMED was picked for the standard terminology just because of its richness and its clarity, and that there's a hierarchy, and the hierarchy is real hierarchy based on true relationships, inheritance of attributes, rather than what ICD-10 does in order to have a reason, like reporting structure there. And there's an organization behind who keeps it constantly going and all these type of things. So it's just it was a choice at some point out of certain quality criteria. And, we don't have any intention to make a different choice today. So SNOMED is the choice here.
Just want to make a final point. I mean, Christian.
I problem child.
No. I mean, I just want to push back on that without conclusion part, because like the patient, like if a patient has a certain diagnosis, diabetes, and on certain drugs, and after 5 years, develop renal failure, there's a pattern, right? You don't need to say that, okay, there's a conclusion. I mean, you can learn from patterns.
Hi, thanks very much for a great debate. So, Will, you said pretty much at the beginning that, 20 years ago when you started sort of in data and AI, people said, you've got to clean the data, you've got to have good data. And, 20 years later, it's still the same. I say that, I'm a chief data officer, I'm say it every day to people. So we've talked quite a lot about sort of the role of SNOMED. And just picking up on your point, Christian, so at the end and sort of Odyssey, how do we see the relationship of common data models? So either OpenEHR and an OMOP in particular, I'm sort of looking at it from a research perspective. Surely there are opportunities there in terms of the the data quality and the investment that we're putting into those common data models. How do you actually see that sort of working and enhancing and accelerating the data quality issues? Because I think that's part of the answer, but I'd love to hear what you guys have got to say about that.
I can probably explain what we do in London. We use OMOP. We have, so I guess first of all, of course, most of the patient data is written in unstructured documents and in many different formats. So we standardize the formats, PDFs, Words, etc., into a single place. We then annotate automatically we annotate all of these patient documents with SNOMED codes, and we map that to an OMOP format, and that's how we store it. So I guess it's just part of that interoperability chain to be able to share, store, collaborate for better research, better, I guess, traceability of the data as well. So hugely important, these different data standards, and SNOMED is a part, same with OMOP, same with FHIR.
Yes, and I believe that the core data models are huge accelerators, because if you want to develop a module for structured patient visits, you probably have 2, 3, 5 years of discussion, and the core data models already had those discussions and embodied into the format. So it's easy to extend. So adopt a core data model, and if you have some needs, specific need, you can extend the core data model with your specific needs. So for me, it's a huge accelerator, and especially to have like multiple visions of data. You can have a core data model like Odyssey for observation, you can have for interoperability, you can have for the semantic layer. So you can adopt as many as it's useful for you.
I think I saw another question over here, or else if not, are there any questions over there? Oh.
Yeah, thanks for a great discussion. My question's about, I guess, the generalization of LLMs. So quite often when you put an input in, the output might not be as detailed as you'd like the answer to be. So some of the NLP tools that use generative AI even if they pull out a SNOMED code, it might not be the most precise SNOMED code. It might be quite a generic one. And we know in medicine, we want as much detail as possible. So kind of, I guess, what are your thoughts on that? And then my second question is about kind of chaining of models. So if we use a LLM, and then the output of that, we stick into another model, and then we build some rules-based system on that. If we know that the LLM each time won't come out with the same conclusion, and currently when these models are being used, there always has to be a human check things before it's used. So if you're asking it to write a business proposal, you'd always want to check it before you start using it. So how do you see that working if we want to start using some of these change models? Because if every time you kind of rerun it, you need a person to validate the output of the first step before you develop step 2 and step 3, then it doesn't feel like it's kind of automating things and making things easier. It feels like it's making things a lot more complicated for kind of the medical staff.
Chain it. The chain of model processes. I think we base a lot of our expectation of what generative AI does. You know, we say, oh, it never spits out the same answer. We kind of base that on the GPT model, but there's some parameters in it that you can change to help standardize. If you wanted to just return me a yes or no answer, there are ways to format in a single word. So that can help standardize the process, but it doesn't break your chain. I think your first question was to how do you make sure they're not creating these SNOMED content? There are also ways to stand up against that and double check if this code that you produce doesn't match up with the real code. Don't use it. Or if there are explicit instructions for what's called instruction or fine-tuning that really help tailor your model following instructions like a recipe. But you have to be very, very in giving these instructions to get exactly what you expect to come out of it. Yeah, so I guess it's a key part. It's really not too important how it works. It's more important is the output what you expect to. Is it?
Of course, the problem with that statement, which is correct, is you wanted to do this and not having to check everything, which is, I think, also the second question that you have. Yeah, if I have to check everything, well, I may as well do it myself. So I have to constantly, like a child doing homework. Trying to put myself into the model, I think what happens is, say you have a medical text and you want to grasp a certain entity out of it, metastatic bladder cancer. And it's pretty sure about the bladder cancer and it's not so sure about the metastatic. The way it reads it, and maybe it's misspelled, whatever it is. Right? And it will spit out what to the threshold that it feels like it can spit out, plus some randomness to it. You can use the parameters to stop that, and it will always, the temperature, you take the temperature down, it will stop doing that. But then it's much dumber because it doesn't then guess anymore. It doesn't like, maybe this is good enough, okay? Then you reduce its ability to, so it's actually, we can't complain. We do the same thing. Okay, we make statements where we're not 100% sure about, but we put it out anyway because I think it's a crapshoot. I may get away with it, and so is this thing. So we really, if we like sit here and saying, "Why does it hallucinate? Why does it come up with a different answer if you ask it a second time?" Well, okay, that's how we work too, and so. From that perspective, if we want to fix it, we have to somehow teach the system or keep asking in certain ways so it can't get out of it to respond to the request. Please be sure. Okay. whatever that means, because it also is a probabilistic number. But at least raise the bar much higher. Okay. And tell me only if you're at that bar, and otherwise tell me I don't know.
And I think we are learning a lot, not only about prompt engineering and parameter tuning, but we are learning techniques. One of them seems crazy, but in fact enhances a lot of the precision. You can even ask 2 large language modules at the same time from different vendors about the same situation. And you can ask a 3rd large language module to compare the answers and see if they are diverging. You can make tools to ask to see if the codes are valid or not. So we are learning techniques to enhance the precision. This one is actually one that worked really great, and asking the LLM to think again at the same case and compare the output, the semantic diversity. So there are techniques that we are learning to enhance the precision.
Yeah, I guess just to add to what the panel have said, it's a really great question. It's a really active area of research and experimentation at the moment. And we are looking at things like how you do better prompt engineering, how you do chain of thought explanations of the model, how you build guardrails to check on the outputs of the model, whether you ask the model 5 times to produce 5 different outputs and then look for the consistency between them, whether you do different things during pre-training. There's a lot of experimentation going on. I think the answer to how you get really reliable outputs is not going to be one single silver bullet. It's going to be the outcome of a lot of very smart, very motivated people trying to crack this problem for the next year or 2. But I really believe they'll get there.
Well, I think that's a great way to wrap up. Thanks so much to our panel. Let's give them a big round of applause, please. So we're going to take a short break. I think we might be a bit early, but that's okay. Yeah, it's going on right now up on the 2nd floor. So just up the stairs here. And we'll plan to be back for 4 o'clock sharp. Thanks again.
They don't.
Yeah.
Hello, everyone. Thank you. Welcome back after the break to the second half of our SNOMED AI Symposium. I'm going to jump right into our next video from A3 Data.
In healthcare, every second, every heartbeat, every word spoken holds profound significance. And every minute dedicated to administrative tasks is a minute diverted from patient care. Doctors frequently navigate intricate coding systems, sifting through clinical conversations, electronic health records, and prescriptions. Mistakes and inefficiencies in this realm, they can lead to denied insurance claims, distort research data, and even jeopardize patient care. It's astounding to realize that time spent on such tasks translates to a staggering $156 billion globally every single year. Amidst all this complexity, SNOMED CT stands as a beacon, cataloging over 300,000 unique medical concepts. And that's without counting their numerous synonyms. The challenge? Manual coding, information extraction from clinical interactions, and ensuring accuracy amidst this vast terminology. Imagine a doctor's conversation with a patient, a discussion filled with medical terms, symptoms, and treatment plans. Now picture this dialogue effortlessly transitioning into precise coded data in real time. This is Nuvi in action, liberating doctors to center their energies on what truly matters. Consider Dr. Martinez, a pediatrician. Each day, she juggles countless patient interactions, assessments, and treatments. With Nuvi, as she discusses a treatment plan for young Mia's asthma. The AI processes the conversation, identifies keywords, and automatically updates Mia's electronic health record, all without Dr. Martinez lifting a finger. Experience medicine at the speed of voice, real-time accurate data extraction, allowing doctors to converse, while Nuvi listens, understands, and codes. The elegance of natural conversation now intertwines with the precision of digital health. For researchers, a goldmine of structured, reliable data awaits, opening new horizons for groundbreaking insights. Governments, institutions, providers, payers, all unified through one language, reflecting Nuvi's innovation, the foundational legacy of SNOMED CT, and FIRE, the standard for healthcare data exchange. Together, we're crafting a narrative where technology doesn't intrude but enhances, where conversations aren't just heard but deeply understood. In alliance with SNOMED CT, Nuvi is not just an innovation, it's a transformation, where technology gracefully complements human touch. At Nuvi, we envision a future where every voice matters and every conversation drives healthcare forward.
Great. Well, welcome back, everybody. I think we've got the hardcore group in here now for the second half of the session. Lost a few people. But it's my pleasure to introduce our speaker kicking off this afternoon. Charlie Harp is founder and CEO of Clinical Architecture, an industry-leading healthcare data quality solution provider. Charlie has over 35 years of experience as a healthcare software engineer focused on creating tools to better utilize and understand data. He led his team to develop the first deterministic algorithm-based engine for automating semantic interoperability. Charlie often speaks on clinical data, quality, and usability, and is host of the InfoMonster podcast. Please join me in welcoming Charlie Harp.
Thank you, Nick. All right, you stayed. I was thinking you'd all be gone. You surprised me. And as Nick said, 35 years, that means that not only did I use 3 different sizes of floppy disk in my time, my early days, but audio cassettes as well in the pet computer. And like a large language model, I have a robust history corpus to draw upon of language. Because I was in healthcare, some of that is colorful language. Now, Susie tasked me with being inspirational at the beginning of this, and that wasn't part of the deal. There's 2 ways I can be inspirational. One takes longer than 10 minutes, and the other is me just saying, have a good night. All right, so I'll do the best I can with the time that I have. So there's a lot of really great discussion today with the panelists and with the keynote. And I think AI is very interesting for me, having been doing this for a long time. AI is a little bit of a different animal than what I'm used to. And one of the things that I think when I think about AI and what we're doing, I think about something that people ask me all the time. I started out outside of healthcare. I moved into healthcare in 1987. And every now and then I run into people that ask me the following question: Charlie, why is healthcare so screwed up? We've got all these other technologies. I've got all this stuff I can do on my phone. Why is healthcare so screwed up? And I assure them it's not because all of us that have been doing this for 35 years are morons. We're not. What I explain is that healthcare is different. And I think that also applies to artificial intelligence. And that's because healthcare, if you think about it, if you really sit down and think about healthcare as a process, it is replete with uncertainty. When a doctor sees a patient, they don't know for sure what's going on. Every patient's different. They basically go through a process which is guessing. Based upon my experience, based upon what I've read, based upon what I know, I think it might be this. They go down a treatment course. Sometimes it works out, sometimes it doesn't. When we put together papers, evidence, all these things, it's all kind of guesses. I think this might be true. So I don't think there are other industries. If you look at banking or accounting or retail, they don't have that kind of uncertainty. And not only do we have uncertainty, but we have what I like to call uncalibrated uncertainty. We're uncertain about the uncertainty. And so when you look at something like artificial intelligence, especially generative models, you have to keep in mind that everything we're putting into this is uncertainty. What we think is true is uncertain. What we say about the patient is uncertain. And the biggest concern I have about generative AI, you know, it's on the hype cycle, the Gartner hype cycle. It's kind of reaching the peak of expectation, and it'll end up in the trough of disillusionment. But just like with NLP, you guys have been around a while. Does everybody remember when NLP was going to solve all of our problems in healthcare? Where's NLP? In the trough of disillusionment. CPOE. I can go through all the acronyms that we're going to solve all of our problems, but they're getting shorter. Now it's just AI. It used to be 3 letters. Now we're down to 2. We have 4, 3, 2. Next one will just be Q. Are you ready for Q? Anyways, so it's one of those things where if you think about uncertainty and you think about artificial intelligence, the thing we have to realize, and this is something I spout off about all the time, this is why this is not inspirational, Susie, I'm sorry. It really is about expectation. What is the proper use for AI, and when are we ready to use AI in healthcare so that it doesn't end up in the trough of disillusionment? Because I think it's a really good technology, but just like anything else, if you live in a neighborhood where all the yards are lava rock and you buy a lawnmower, you're not going to be happy with your purchase. And you're going to say, lawnmowers suck. They don't do anything. And that's the risk we run in healthcare if we try to do something before we're ready. The other thing I talk about all the time is data quality. And data quality in healthcare, because of the uncertainty, because of the way we collect data, because of the way we try to use data, our data quality in healthcare is a big problem. It's a very big problem. We did a survey, Clinical Architecture did a survey, and we're going to do the same survey every year about data quality. And we ask people, how do you feel about your data quality in your organization across the different verticals of healthcare? And most people thought their data quality was meh. We think it's okay, not good, not really good, but it's meh. And they also felt like data quality was critically important in what they do. The only thing they thought was worse than their data quality was the other guy's data quality. Our data is bad, their data is super bad. So what that means is we have all this data in healthcare, and we really desperately want to use it because a lot of the things the speaker said was true. Healthcare is inefficient. Providers are getting burned out. We're losing providers. We don't have the same level of experience. So we need to augment those providers with other resources that can help them. I mean, one of the things we do at Clinical Architecture, and we've been doing it since 2009, is deterministic logic. So whether it's semantic interoperability or inferencing, or even things like extracting unstructured text, structured data from unstructured text set sources. But it's deterministic, because that's another problem we have in healthcare. It's accountability. We didn't say that during the session today, but when you say, hey, humans make a guess, and sometimes they're wrong, and I can sue that human off the face of the earth. I don't know if I can sue an AI. I don't know how that works. I don't know if that AI is going to go home at night and say to his wife, I might have really hurt this guy today because I didn't know for sure what I was doing. So that's the other thing. So to accommodate that, when you look at all the things we do with computers in healthcare, what do we have? We test things, we certify things. And how do we do that? We put input in, we say, this is what we should get, and we get input out. That's hard with AI because AI, and it was discussed again today, it's a probabilistic machine. You put data in, it goes through a process, you get different data out. How on earth is the FDA going to test that? I don't know how. So it's one of those things where when you consider our data quality, when you consider the criticality of what we do, I'm not saying that AI, generative AI, super AI, whatever, Q, I'm not saying that it's not going to work. I'm just saying we have to understand when we're ready to make it work. And here's my advice to you. And I say this to people coming out of Silicon Valley all the time. We're like, I'll just disrupt healthcare. I'm like, healthcare is disrupt resistant. Most people that try to, they end up in the trough of disillusionment with these other technologies. You cannot disrupt healthcare. It's critical. It doesn't move fast, and it's incredibly expensive. So you think you can jump in and disrupt that? You know, a lot of us salty dogs who've been around a while kind of sit back and say, okay, well, we'll see how long this lasts. In my opinion, progress is made in healthcare through small, incremental steps. Progress is small, incremental steps that evolve how we do things in a way that we feel is safe and appropriate. And so now I'll talk about SNOMED. I'm not going to roast SNOMED, don't worry. I think when you look at terminologies, I think terminologies are important. And I believe it was Christian said it earlier today. He said, facts. If you're going to make decisions, those decisions should be about facts. And I think that the benefit of taking data and putting it into a structure, whether you pick something from a list or whether you have an AI put things into structured data format, however you get it there, somebody acknowledging that these concepts are true, hopefully, and correct, and they put that into a machine, you need terminology to do that. Because for me, if I was having a conversation with one of my colleagues yesterday who said, Charlie, they're just going to type in free text and AI is going to figure it out and give it to this next thing that AI figured out. What is that? Say it with me. It's uncertainty. It could be garbage, Rob. That's true. But it's one of those things where now someday we might be sitting, my brain will be in a jar and it'll be articulating. Remember that time I said that AI won't work? Maybe in the future, we'll figure out how to make it all work. Maybe we'll find a way to transition, because I believe there is a way to take the natural language of a provider or other caregivers and turn that into some kind of a structured graph that is computable, because that's what we don't have today. Everybody has a local terminology, which is kind of a necessity in some ways, because healthcare evolves from the edges, not from the center. We translate that into a normative reference terminology like SNOMED and its siblings kind of out there in the world, RX norm and LOINC. So or OMA. So once we get it in there, we can reason over it collectively in an aggregate. We need that. And we should be able to give that to something like an AI or, heaven forbid, classical analytics. It's one of the things I think is kind of amusing. We haven't mastered classical analytics in healthcare. We struggle with quality measures in healthcare. So, and that's all about quality. So I think for us as an industry, how am I doing? Okay. I think for us as an industry, I think that we really need to look at the quality of our data. And I think as bad as it was, one of the positive outcomes to come out of COVID is that people finally woke up and as a data company, first of all, my company does data quality, interoperability, terminology. If the AI guys think they're boring at a cocktail party, don't even start. Nobody wants to talk to me. But it's one of those things where, where's I even going with that? I'm boring. What else? I'm boring. I'm senile. I'll weave it back in. But the bottom line is we need to be able to take the data, put it into a structured format that we trust. We also have to figure out time and how time works, because everybody that works with EMRs knows that the way they fix time is they just stop deleting things. That doesn't create a continuum. It just creates a big landfill full of legacy data that you don't know if it's current or not. So we have these fundamental problems, and AI might play a critical role in solving some of those problems, like being able to produce a clinical summary. You know, when we were talking earlier today and we said, well, if we took a patient's clinical record and we put it into an AI, what could it do with it? One of the things it theoretically could do is it could summarize it and say, this is old data, this is new data, this seems to have fallen off, this seems to be current, these are the medications they're on, they're not on that medication anymore. So maybe one of the things AI could do is make it so that somebody doesn't have to look at 1,800 pages of documentation. Maybe there are other things AI can do. Maybe we can apply AI to do things like clinical decision support, but we still have to solve the transparency issue. The other thing that we need to, and this is kind of a SNOMED thing too. The other thing that we struggle with in healthcare, especially with AI, is this idea of resolution. If you think about it, in healthcare for the last 30 years, we've used pre-coordinated terminologies to do everything. And I'll give SNOMED a lot of credit in terms of post-coordinated expressions. They were kind of on the front of that, and it's hard. People don't know how to wrap their head around post-coordinated expressions. But when you think about pre-coordination, think about it. In our industry, this crucial industry we're in, a doctor, to create structured data, has to take what they're thinking, go to a list, search the list for something that's similar to what they're dealing with, and pick it to put it in the structured data. What is that? This is your second chance.
Yes.
Uncertainty. So we have the situation where we can't really express the clinical scenario with the same or near the same level of detail that's in the provider's head. When I was at FDB for 10 years and we did drug interactions, we took the stuff that we had deployed in the pharmacy and we tried to take it to acute care and ambulatory. And you guys, it's history what happened when we tried to do that, and other vendors like us. People shut it off. Why do they do that? Because the drug interactions say if you take chiclets and Tic Tacs, your head's going to explode. And we have some reason to believe that. It was lacking granularity, because what the evidence actually said is if you take chiclets, this isn't true, you can take chiclets and Tic Tacs together. There's no duplicate therapy. But if you have really bad breath, you can also throw in a Mento. So if you take chiclets and Tic Tacs and you're 90 years old and you're diabetic and you're a smoker and you have this genetic variant, then your head's going to explode for sure. We also have to figure out how to solve the granularity problem in healthcare. Because as long as we are dealing with these big pixels of information and we feed those to an AI, the picture that it's dealing with is fuzzy and it's always going to give us wacky advice. So we have our, I guess what I'm saying is, if you're worried about job security, you're good. By and large, in healthcare, we still have a lot of work to do. I think AI can help us. I think the idea of having AI help curate some data. I happen to think the role of AI is a support role. I think AI doing things and presenting it to a human and saying, hey, I've looked at petabytes of data and I see a pattern that no human would ever be able to see on their own. And I've been able to isolate it to these SNOMED codes. I think that's the kind of thing where AI can really, really help us in the short term. I just think that the risk we run if we try to incorporate AI into clinical practice and it kills somebody, which, I mean, Watson Health struggled with something like that in the not too distant past. We've seen a preview of this. What it does is it undermines the credibility of the technology. And all it does is kick that can further down the road and decrease the likelihood that we're going to see adoption in a practical, useful, reasonable way. Now, do you feel inspired? All right. You're like, just get off the damn stage, man. All right. That's my TED Talk. Thank you.
Really, you're always inspiring. Come on. Come on. You know this. Okay, and so to wrap up today, last but of course not least. Come on, Rory. Come on up to the stage. So coming up to the stage is our Chief Information Officer for SNOMED International, Rory Davidson. He's responsible for the effective integration of SNOMED International's content development and technology teams to ensure that the delivery of SNOMED CT and relevant technology services continue to meet the high standard and expected outcomes of our members, of our wider community, of course, all of our internal stakeholders. Previously, Rory led the SNOMED International Technology Services Group, ensuring that the technology platform was put in place to ensure the quality, maintenance, and delivery of SNOMED CT, as well as the day-to-day operations at SNOMED International. And he and his teams still do that today. Yes. So without further ado, Rory.
Thank you very much. This is the one day to get imposter syndrome. And lucky being at the end, lucky I'm not saying anything completely contradictory to what was said before. Yeah, thank you very much, everybody. You've all heard me speak at least once over the last 3 or 4 days. This is the last time, I promise. It really is. And I'm just give a quick brief on where SNOMED and SNOMED International is with AI, and also an exciting new challenge that we're going to launch today. So, and some of this is repeating quite handily. I mean, Charlie, you literally took half my, sorry, but that's fine. No, it's good because you presented much better than I can. So we talked about AI, and on the panel earlier on, we had some great kind of explanations. What is large language models? But again, that's just one of the AI things that we talk about. And I've nicked this off the internet legally, obviously. And there's a lot we talk about. There's a lot of technologies in here. It's kind of a theme of everybody getting up here saying, I've been involved for a long, long time. I remember studying expert systems, and that was AI. And, you know, keeps on going. And we'll keep on calling it AI, but it'll be another new term as we go forward. But it's a rapidly moving industry. And as we know, the reason we're here is because at the beginning of this year, or just at the end of last year, you know, the infamous appeared, I don't want to say it, and we moved into large language models, and we were able to start playing with AI and seeing the future, and jobs are going, and the robots are coming, and lots of pictures of the Terminator. But the reality, that's not really where we are. I mean, handily, I do have the hype cycle for AI. And the hype cycle is great. The Gartner hype cycle is always a really fascinating thing. You look at it and you go, that's not true. But then it's always pretty on the spot. I'm not coming up, I'm trying not to be I'm not being disparative or too cynical either, but the fascinating thing for me is you just see where things are on the curve. There's a lot going on in this domain, and a lot's just on the way up. And there's not much on the other kind of way coming down. And some of those things take a long time. You know, this is not an easy world. It takes a long time. It needs compute power. It needs cost. It needs skill sets. It needs people to understand this stuff. And we've got a way to go. However, it's coming. And I think what we're going to see is that hype cycle is going to take a look. It's going to get shorter. It's going to happen quicker. We're still not going to see the magic in 2 or 3 years, but in 4 or 5 years, we might start to see these things starting to happen. So what does that mean for SNOMED International, SNOMED CT, its members, the community? Well, we started to think about, with artificial intelligence, what can we do? The organization is a standards organization, as a global standards organization, we're ideally placed to try and provide some thought leadership. You know, we're not saying that we are experts in this area. We work with the experts. We bring the experts in to help us. But if we can help provide some messages to governments, to members, to implementers, to all of you, I think that's only a good thing. It's about sharing knowledge so that we tackle this in a safe and consistent way. So we kind of think about this from really 3 things. You know, how is AI going to impact us? Product. There's going to be impacts on, SNOMED CT as a product. How can we improve it? Can we improve it? How do we make it more relevant? The organization, people have mentioned how part a lot of the technologies that these come in this area are around getting efficiencies, taking away the dull administrative work, making that happen with other tools. And then how do we help our members, the implementers, and the community? How do we get SNOMED more adopted? How do we make it easier to use? How do we make it get it into patient records quicker? Ultimately, that's why most of us are here, is getting SNOMED CT into a patient record so we can get into the analytics, albeit not great yet, going in the right direction, which can then be fed into all these models, and we can see some of the great things that we do expect to happen. So we've put some of these ideas together, and these are just the general themes where we're kind of going down. And none of this is particularly shocking, none of it's particularly revelatory, but thinking about how we can use SNOMED or AI rather with SNOMED to support implementation. And this is around translation. And what can we use with these new technologies to translate SNOMED quicker, easier? Not necessarily replacing translators, but making the process more efficient. How can we use it to generate extension content? The areas of domains that we haven't yet covered, there are gaps. And sometimes these are local more than global. So can we use these tools to do that? The obvious one is how can we get SNOMED CT into some of these models that are out there? I think it was Anthony gave a great response to that in the panel. We don't really want to. It'd be nice to, but the reality is, little SNOMED International knocking on the door of OpenAI or Google doesn't really get a lot of responses. However, building those agents around it to provide the guardrails so you can use SNOMED in the most appropriate way, I think that's the powerful place to do in this. And can't see another. So the implementation team, Alejandro in particular, has built some great demos on how we can do some of that stuff. And so we keep on doing this, keep on showing thought leadership on ways to do it. Not necessarily doing it ourselves, but showing you how it could be done. How can we use AI to enhance the user experience? One of the most frustrating things working at SNOMED International is that we have zero impact or zero influence on the software providers that provide the healthcare software that people use. I still see green screens from time to time. How do you improve all that? Can you use AI to demonstrate how you can get some of these technologies at that user experience, making it easier to use? And the extremely well-produced video we just had with the great music, the music. You know, I've seen there was an epic one I saw, a similar thing that is something similar where the doctor walks in, the very cute kid looking in the eye and he's speaking, and it's actually just coding things on the fly. Now, probably not exactly there, but we're on the way. And that's another example of what the end user experience is. From the product point of view, we can use it to support modeling and quality assurance. We know there are gaps in SNOMED. You know, there are 360,000 concepts. How many have we not looked at yet, Jim? Probably. I was hoping for 40, but okay, 60%. And we need to improve that because there's lots of primitive content. How do we improve the modeling? So if we don't improve the modeling, it's not going to be as good in analytics. It's not going to be good for these tools. So can we use these tools to improve the modeling, identify the things that need to be fixed or the things that are missing? And finally, the one that's the kind of popular one is how do we get machine-assisted clinical coding? There's volumes of unstructured data out there. It's a sweet spot. How do you get that data clinically coded? And there's lots of work going on. Anthony talked about what they're doing down in London. I mean, lots of people looking in this area. The biggest challenge with all of this stuff, as we all know, is there's not really much data to use. There's not data to play with. There's not a lot of public data. So you're either limited to what you have access within your organizations or your healthcare environments. But if you're not working in a hospital, then or in a healthcare situation, it's really hard to get this data. In fact, it's done. So we have created an NC-Link challenge, very exciting. And we're working very closely with a couple of partners, primarily PhysioNet, Verify, and Driven Data. So this is really, can we do NC linking? Can we produce models to improve the structure of that unstructured data? The reason we're doing this is essentially to automate the coding, so we improve interoperability, decision support, and improving healthcare delivery. So that's the strat line, that's the mission statement. But this is the mission statement for any kind of clinical coding, and this is what we're trying to do. But it was really important that we got a data set. And so we've kind of been in touch and worked closely with the PhysioNet team at MIT. Some of you may know them. They've been around for a while. They're funded by NIH. They basically are responsible for the MIMIC data set. We started looking at MIMIC 3 about a year and a half ago, and now MIMIC 4's come out, and there's a massive amount of patient records, anonymized patient data. Come from the Beth Israel Medical Center in Boston, got more than 40,000 patients. I think it's about a 7-year data period. And it's extensively used by people who don't have access to healthcare records, of which most don't. So it's been used in research, education, and industry. However, there are no SNOMED codes in there. There's a lot of ICD, but we know that we need that richness from SNOMED CT to get the precision that we're talking about. And so we need to figure how can we build that data set in there. So we work very closely with them to produce a data set and did some annotation. So we spent 2 months over the summer working with MIMIC 4. There's 6 annotators from the SNOMED community, most of them you will know. And we did 70,599 annotation items across 272 documents. It was a lot of work, but it was one of these interesting pieces of work where we learned a lot more than we thought we were going to learn. Because this is what people do, clinical coders, they annotate. And when we're annotating, we realize, no, it's not that easy. we found, for example, that when we started, we were using the situations with context hierarchy. And that involved half-hour discussions over one annotation because of the disagreement or the ambiguity about some of the area of the hierarchy. So we decided to remove that. But then we basically got to built up the process. We built up some great annotation guideline document, which actually shows rules and how to annotate SNOMED, which itself is a great outcome of this. And we've got a report about the lessons learned that we're happy to share if you'd like a copy of that. The really important thing is we were looking for inter-annotator agreements, and that's really the key one. You don't want it too high because then it's just too easy. You don't want it too low because then it's impossible to finish. And so we got to about 0.83%. We got a good score. Happy with the quality of the data as well. We've checked it a couple of times. We're very closely with Will, the back is on the panel. And really the key thing about this, it was much more ambitious than we thought it was when we set out. It's now probably the largest openly available clinical annotation data set with SNOMED CT in it. So this is now what we're going to use for an entity linking challenge, which has a prize. Woo! And so there's a prize for the challenge. There's a prize pool of $25,000 US. And we haven't worked out exactly what that pool, how it is, but that will be the total. Because we want to get people involved. We talked to, so Driven Data is the organization that we're using who hosts the challenge. They work with obviously companies very similar to us, like NASA and those type of people. So so they've got a good experience, and they do these things it's kind of a goodness, for good outcomes. Basically, they are non-profit. They want to make this work. So we work very closely with them, and they recommended this kind of cash prize would get a good kind of response from the challenge. So it's about getting more people involved. Some of these people never have heard of SNOMED. And that's also good because we're introducing SNOMED to a whole area that's never looked at it. So it's about an introduction to software developers, other implementers who probably aren't even in healthcare as well. So, and it's a good thing. You know, it's hard to say having structured data in healthcare data is just a good thing. So this is why it's like a nice sales pitch, really. So the registration opens now. How exciting! So you can go to the site, you can register. At the same time, because this is data, mimic-4 data, you do need to get permission. You register on PhysioNet, and there's like a two-hour or so course around essentially using essentially patient data. They do that on purpose. You know, they're responsible for the use of that data from the Beth Israel Hospital. So it's really important that people do that. So you can go ahead and do that now. The plan is all going well. The challenge will start early December, run for about 3 months until mid-February, where you'll be able to build models, submit containerized code, and run it and see what the scoring come back. We'll have leaderboards, all these types of things to track where it's going to till the end of the challenge. And then it will finish mid-February, and we would announce and do any prize awarding at the business meeting in London. Key things to take away at the end of this. The winner will be open source licensed. It won't be closed sourced. It's not going for commercial purposes. It can do, but it's open source. Other people can use it. But also, again, back to one of the great outcomes of this piece of work is that data set of annotations will be donated back to Mimic4. So that will then be available to the rest of the research community to actually start using SNOMED CT in their research development. So that's pretty much it. Go. For those who like stickers, I have some stickers. You always want stickers for software developers. Please go to the website. There's more information on there on how to register at PhysioNet. We're really excited about this. It's a new thing we've not done. The plan is this is the first time. One thing is very, very clear. This is the first time with English data from a very particular part of the US. This is one of the things with these data, as we all know, it's not going to represent what happens in London, or maybe not London, but somewhere else it won't. I think this is the first time to see how this works and how it's success, what the results get, what's the interaction, who gets involved in this. That's the fascinating thing. So we do expect to do another one next year or the year after, probably focusing around language, different languages. We focus very much on English. We're all speaking English here, but it's also just one of the languages. So we need to focus on other languages. So thank you very much. Enjoy, go, sign up. Have fun. That's it. Okay, Susie.
Thank you, Rory. And we hope that you guys are really excited and spread the word. And also, if you can, enter. Oh, questions. You want to do questions? Okay.
Jump the gun.
All right. Just kidding. Hold the wrap up.
Susie is going to ban me. No, just a serious question. So any restrictions to entry, for example, like, I mean, employees of SNOMED International, NRC members, workers, are they restricted? Second question is, how many teams, can like, for example, if we want to participate, can we enter multiple teams instead of just one?
Sounds like you're planning for Christmas. So the reality is, from a SNOMED International point of view, yes, staff can't take place because they have access to the answers. However, outside of that, that is your local organization policies about what you can and what you can't do. There's no limitation to teams. You can have multiple teams. It's entirely up to you, and if you're allowed to. But I can't say if you're allowed to or not. I get told off. So yeah.
Fair
But yes, not SNOMED staff. Sorry.
Yeah.
Sorry, SNOMED team.
No, fair enough. Fair enough. Any other questions?
No, I'm not talking about Loink again, Rob. No more Loink.
But I'm trying to figure out. So first off, you're saying it's launched, but it's not launched on the website yet. You've got to turn it on. It says pre-launch right now, but I always keep finding these things with your websites. You know that, right?
I'm so glad you're back.
But I'm trying to figure. So I'm assuming the gold standard is concept linking to patients. It doesn't say that, but I'm
So these are essentially clinical notes. So you're taking these 272 documents that have been annotated. We'll keep some of that for the gold set and some that's used for training data.
Okay. Okay, so that wasn't clear. So it's all notes. Everything in the corpus are notes. So the entity that it's linking to is a note, not a patient. You see what I'm saying? That like the
kind of, it's linking the entities. It's linking
it,
the entities within the notes that you extrapolate from the
right,
information.
If you had test results and you had other things, you'd have to link all those together to a patient in order to say, I've got 80% of the concepts for this patient, but you're doing notes, and so
this is essentially taking handwritten unstructured patient notes.
80% of the concepts across the notes. Okay, good. Yeah, awesome.
It should be live. So I don't know. There should be a registration. It should.
I was going to say.
It just says pre-register.
Yes, that's register. Okay, I'll take the word pre off, but it's okay. Semantics. Oh, I forgot. No, so you can
Michael and then Charlie.
So I'm going to ask about the open source clause. What does that mean if you've got an underlying language model? That open source for building the model, the data to generate the model, what constraints might there be on the model itself?
I think that's a good question. Part of the reason we're kind of registering now is some of these final details we're working out over the next, basically put together the competition rules, which is exactly what that is. The outcome intended is, yeah, of course, if you build a whole prompt chaining on top of OpenAI, we're not asking for them to, open source that because they won't. But it's about the stuff that you build should be available on open source, even if the underlying stuff isn't. There's another question. Yes.
Charlie?
What if, say, somebody who couldn't do the open source option wanted to do it for the fun of it, not to actually win anything? Would you allow that? Yeah.
Yes, exactly.
Steve wants to know.
I don't know why not. Suppose so, yeah.
Cool.
I don't know. I honestly hadn't thought about that because we're all for open source. I don't know. Again. Yeah, yes, exactly. There you go, Steve. Yeah, if you win, you have to make open source. You have to get a second and aim for second only. Great question. We'll find out.
And I could win up to 25,000?
Up to.
Oh, okay. Well, then absolutely.
Okay. That's a range.
You mentioned that in the human coding that you had an 83% interoperator reliability, which is met. Is that the benchmark for do you expect that to use as a benchmark for the AI coding then, or how do you look at that interoperability and see comparing that to an AI effort as well?
It's a good question, and so Will and I have this question back and forth. You could say that a low interoperability IAA is actually a reflection of the real world, because most annotators do not annotate the same way. So I don't think we were talking about, do you synthesize some of that and maybe make it a little bit more, but that's not what's really out there. So having that type of difference, I think, is acceptable. As I said, we learned a hell of a lot with the annotation that we hadn't expected to as part of this project about what are the challenges of annotating SNOMED CT into patient data. And that itself is a great outcome. And it kind of shows that we had to, I wouldn't say we didn't tweak the data, but we had to have triple reviewing of some of the annotations to try and get to a point that actually we had more confidence in coming through. So we've made sure that we could get the best we could without going too far, if that makes sense. So for this data set, I think it's okay. I don't think you're going to get better in the reality of what our lessons are for the moment. So SNOMED's such a large corpus to work with. It's the precision thing again. Which one are you choosing? There's a lot to choose from. So it's difficult. I think we've got a good set. We're confident in the quality of the set. We've run, I think Will said he ran a quick run through MedCat and got out with a half decent score. So it shows that we're in the right direction. So we will see. And again, like all these projects, like anything in this, any new technology, any innovative technology, there's always a risk that it will fail. Failure is also okay. I mean, it's not great, but Don won't like it. But failure can be okay. And if this comes out and says that actually this is something much harder than we think, that itself is a good finding, a good outcome. So to see. So we'll see. I mean, we're happy with it. We're very confident with the data set. At one point, we weren't too sure, but we've got a much better feeling of it now.
Any other questions?
Yeah, I'm assuming you've not run it through ChatGPT yet, right? Or did you?
We can't.
Yeah.
So it's an NIMIC 4 data set we cannot run through because it's public data. So it's healthcare data.
Right. Okay. Yeah, it's going to actually, it's going to be a really interesting thing if you get a couple of entries in here that are actually hard to discern the difference. How you're going to decide what's right, what's the best, right? I mean, you're almost going to have to send their stuff back to your annotators.
So there's a whole, and this is where my level of knowledge goes way over, and I look at like Will over it. But there's a whole scoring mechanism that's built into these platforms to pick those types of things up. So and we're working out exactly how we're going to do that scoring. So by the time we go live at the beginning of December, the competition rules we laid out, the scoring mechanism, how we score it exactly. But it's not scored with human beings. It's scored against the machine.
Well, it gets. I'm going to start going into rabbit holes, but it gets to this whole idea about what are good agents, right? I mean, one of the things that comes out of this is how do you decide in something that, like, I mean, I agree with you. I think 83% is probably as good as you get, particularly when and I know, Brian, what how messy SNOMED is with regards to representing real data. And so this idea of, and I think we do need to do a good job of designing agents that can be made available to organizations so that they can incorporate SNOMED with guardrails. I think that's like a huge goal. That's great. It should get us closer. So thinking about how get back can tell us something about how those agents should function would be a really good outcome.
And absolutely, part of this is the fun of the competition, but the fun is to see, it's the good old eating our own dog food. We talk about all this stuff. Well, let's do it and see what the outcome is in a way that we can share it, because it's, we're not working in a closed environment. So yes, 100%. That's really one of the reasons we're doing this. So.
Hey, great announcement. So yeah, I think this is a big contribution for the NLP community in particular. There's not much out there on SNOMED. It's all, as you've mentioned, ICD. A few little clarifying questions. So the annotation itself is on a dimension level, right, of the entity and text. And to the evaluation, I assume is based on exact matching of codes. I know you mentioned jacket, so I assume it's a one-to-one match of the exact code used, not any sort of distance metrics or.
I'm going to ask Will to pick up the microphone and answer that one.
Yeah. Hi, can you hear that?
Yep, yeah, I can hear you.
Yeah, so the annotations are on a per mention basis. So there's per clinical note, depending on the length of the note, you'll find a few hundred annotations in there which have been linked to the concept base. As regards to how we calculated the kind of the Jacquard similarity score, that's looking at if two annotators took the same note, had to both detect all of the concepts and link them to the knowledge base, you know, what's the result you get out the end there. When it actually comes to scoring in the competition, we haven't got to the bottom of how we'll actually do the evaluation, because there is some notion that, you know, if you two very similar concepts in the concept tree, it doesn't necessarily mean it's a mistake if you don't pick the right one. The difficulty is, of course, finding a scoring metric that is going to work as an implementer of this algorithm. You want to be able to train against it.
Yeah, thanks.
Yeah, go on.
Post-coordinated expressions.
Yes. What?
You
No.
can link to single concepts or link to post-coordinated expressions.
Concepts. Concepts.
No.
God, it's like you guys want everything on day one. So, not yet. No, this is single concepts. Yeah.
This is why I didn't take questions. Sorry.
I didn't think.
Especially with Rob McClure in the audience.
I blame
Rookie mistake.
Kinwar started it. Ah.
Okay.
Okay.
Did you have any final things?
No, I'm done.
You're done.
Oh, God.
It's good.
Okay, yes. So the SNOMED, I guess, AI Symposium team here just wants to thank everyone for attending today. This was our inaugural AI Symposium, and we hope to have another one next year. And yes, I hope you guys learned a lot. We're inspired by all of our presenters today. And thank you, and we'll see you again next year, and enjoy the as we go into Expo the next couple of days.